Hello, aspiring programmers. Today we're embarking on an exciting journey through the world of web development with React, specifically focusing on integrating Google Maps into our applications. Our goal is to create a web page that not only shows us a map, but also pinpoints the location of all nearby coffee shops from a fictional current location in Venice Beach, California. This tutorial is especially useful for those looking to understand how to work with APIs and React applications, enhance user interaction by displaying dynamic data based on location, and perform distance calculations between different points on a map. Imagine the convenience of opening a web page and immediately finding all the cozy coffee spots near you, complete with distances. This is not just about learning to code. It's about creating practical, real-world applications that enhance user experiences in meaningful ways. Whether you're building an app for finding the nearest coffee shops, restaurants, or any service, the skills you learn here will serve as a solid foundation for your future projects. Integrating Google Maps into your React projects can seem daunting at first, but fear not. We'll break down the process into manageable steps, from setting up the Google Maps API, fetching coffee shop data using the Places API, to calculating the distance between your current location and the shops. By the end of this tutorial, you'll have a functional map-based application that could very well be the starting point for your next big project. So why is this code useful? It teaches you to interact with two of Google's most powerful APIs, handle state and lifecycle in React, and apply practical math to solve real-world problems, all while creating an app that could easily be expanded into something bigger. Plus, it's a fantastic way to make your web development skills more marketable. Now let's dive into the code and start brewing some fresh, hot knowledge on integrating Google Maps into your React applications. The code begins by importing necessary React hooks and components, along with the Google Maps React library. This setup is crucial for leveraging React's component-based architecture, allowing for efficient state management and lifecycle methods. The useState hook initializes two pieces of state: coffee shops, which will store an array of coffee shop objects fetched from the Google Places API, and selected shop, which manages which coffee shop, if any, is currently selected by the user. The use of state here is key to creating a dynamic, interactive user interface that responds to asynchronous data fetching and user interactions. The UCJSA PI loader hook from the Google Maps API library is used to asynchronously load the Google Maps JavaScript API. This step is critical because it ensures the API is fully loaded and ready to use before attempting to render the map or fetch data from the Places API. This hook takes an API key and other optional parameters like the libraries needed. In this case, Places is specified to indicate the use of the Google Places, a PI alongside the Maps API. Ensuring the API is loaded before proceeding is a best practice to prevent runtime errors and improve the user experience. Once the API is confirmed to be loaded, the useEffect hook triggers an operation to fetch nearby coffee shops. A new map instance is created but not displayed, serving as a hidden container for the Places service to operate within. The Places service then takes a request object specifying the current location, search radius, and type of places to search for, cafes in this case. This operation showcases the integration of the Google Places API, which is designed to return information about places in response to queries. Fetching this data asynchronously and updating the coffee shop state with the results allows for a dynamic and interactive map that displays relevant, real-time information to users. An essential feature of the application is the ability to calculate the distance from the current location to each coffee shop. This calculation is done through a straightforward geometric formula that considers the Earth's curvature, providing an approximate distance in kilometers. This functionality enhances the user experience by offering practical information, helping users gauge how far they are from each coffee shop. This calculation is a good example of integrating custom logic with data fetched from an external API to create a more informative and user-friendly application. The rendering logic of the component is designed to display a hero banner, a list of nearby coffee shops with their distances, and a Google map with markers for each coffee shop. This setup utilizes React's declarative UI paradigm, where the state dictates what the UI should display. The Google Map component from the library renders the map based on the specified container style and center location. Markers are then placed on the map for each coffee shop, and an info window can be opened for the selected shop, providing more details to the user. This part of the code exemplifies how to create a rich, interactive map interface using React components and Google Maps API. Throughout the code, the integration of Google Maps and Places APIs is central to providing the functionality of displaying a map and fetching data about nearby coffee shops. The Google Maps API is used to render the map and markers, while the Places API is used to search for coffee shops in the vicinity of the specified location. This integration showcases the power of combining these two services to create interactive and dynamic map-based applications that can provide users with valuable information about their surroundings. In conclusion, the provided code demonstrates a practical application of integrating Google Maps and Places APIs within a React application to create an interactive and informative map experience. By breaking down the code step by step, developers can gain insights into how each part works together to fetch, display, and interact with data from external APIs, all within the context of a modern web application built with React. As we wrap up our deep dive into integrating Google Maps and Places APIs with React to create a dynamic map displaying nearby coffee shops, it's important to consider how such a component fits into larger web applications. This exploration not only showcased the practical application of these powerful APIs, but also illuminated key development principles such as extensibility, reusability, and efficiency that are critical in the field of web development. Extensibility is a core feature of this component, allowing developers to easily add more functionalities, such as filtering coffee shops by rating, offering directions to a selected coffee shop, or even expanding the search to include other types of places. The modular nature of React components makes it straightforward to enhance and expand this application without having to rewrite or significantly alter the existing codebase. Reusability is another significant advantage. The component we've created can be adapted and reused in various applications that require map functionality. For instance, it could be repurposed for finding restaurants, parks, or any location-based service by simply changing the types of places we're searching for in the Places API. This reusability saves developers time and effort, enabling rapid development of feature-rich applications. Efficiency is achieved through the use of modern JavaScript technologies and the React framework, which ensures that the application runs smoothly and responds quickly to user interactions. React's efficient update and rendering system means the map and list of coffee shops updates swiftly when the data changes, without reloading the entire page. This leads to a better user experience and more interactive web applications. Incorporating these APIs into larger applications opens up a world of possibilities for creating location-based services, enhancing the functionality and user experience of web applications. By adhering to development principles and leveraging JavaScript technologies, developers can build sophisticated, efficient, and user-friendly applications. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video to be helpful, please like and subscribe for more of the same. Thanks again, and remember, we're always learning, so keep coding, keep exploring, and keep building amazing web applications.